Today we will discuss about switching concepts here. So as we discussed before for routing, so what is the basic difference between routing and switching? I'm not going through the slide now. I'm just telling you about the basic difference between routing and switching. So when we talk about routing or router, there are two different network involved. So basically when we want to communicate between two different networks, we need a router. Without router we cannot communicate between two different networks. But by using switch we can communicate only between devices who are in the same network. So I'll just try to explain you with a normal diagram. For example, you'll see here it will say routing, and it will say switching. When we talk about routing, there is two PC. PC means our computer. So PC1 router, PC2. So this PC is in 1.1.1/8. Two dot one dot one dot one dot which has 8. So you can see PC1 is in 1.0.0.0 network, but PC2 is in 2.0.0.0 network. They both are in different network. So if you see here, this is in 1.0.0.0 and this PC is in 2.0.0.0. So we need a if we want to communicate between these two PCs, we need a router because they are into different network. Let's switch. It will place a switch here with the same IP address, same. We can't communicate. This will not work. This will not allow to communicate. So in this case, by using switch, if we are communicating, all the connected devices or all the connected PCs or devices we can say should be in the same network. So PC1 switch PC2. So this PC is 1.1.1.1/8 1.1.1.2/8. So here you can see /8. Both the devices, both the PCs are all the devices connected to this switch SW are in the same network 1.0.0.0. That's why the switch will allow. The switch will allow only communication within same network, but switch will not allow if multiple networks are involved. It should be very clear. Now we'll go to the slide. So switching is an approach of delivering frame across the network. switching method decides how a switch receives, processes and forwards the frame. So how it will receive a frame, how it will get processed, like what all information it will look for, into the frame, and then how it will forward the frame depending on the information. So that all will be decided by switching method. So before going for switching, we'll have a brief introduction about hub and repeater. So what is hub and repeater? Hub and repeater is a layer 1 device. So in a simple way we can say, like, it is not having any intelligence. It will just receive one signal and it will transmit it, it will forward it to all other ports. Suppose 4 ports are there, it will receive port 1, port 2, port 3, port 4. So it will receive a signal from port 1 and it will forward that signal, that received signal, to port 2, port 3, port 4. So they will just understand the signal, they will not read anything. Signal received, as I told, signal received on incoming port are forwarded from all available ports. So bridges and switch work at layer 2. So here what is the difference? Switch works at layer 2, but layer 1, that is hub and repeater, they works with signal. They will receive signal and they will forward it to other ports. Bridge and switch both are capable to read frames. So bridge and switch both uses same concept, same intelligence. Bridge previously was having very few ports and later on switch came. So we can say bridge and switch are having similar technology. So now we'll term it as switch only. So bridge and switch both are capable to read frame. So they will receive frame, they will read the frame, and depending on their reading they will make a decision of forwarding. So switching is a method of dealing with the frames. So switching is described in layer 2 of OSI model. So as I already told, we need knowledge of OSI model, at least basic flow of OSI model, to understand the basic working of the switching and routing methods. So switching is described in layer 2 of OSI model. So as I told, switch is upgraded version of bridge. Bridge was earlier implementation that has been replaced by the switch. Switching concept was developed to solve two major issues of Ethernet, that is bandwidth and collision. So bandwidth and collision was two main problem in the layer 1 devices like hub and repeater. So switching concept or switches solve that problem for us. So collision means when we talk about bandwidth, so at what speed our data will get transferred. Like we'll say like this, our internet is giving this many Mbps, kbps. So that is the bandwidth. As we can see, bits per second or multiple of it to measure the consumed or available data. So when we are working with layer 1 device, bandwidth is a big problem because lot of collision will take place, so we'll not get that much of bandwidth. Now what is collision? So collision means it is simple example like in the same road, two are coming from a different direction, they will get collide. So suppose car 1 and car 2, they both are using the same road, same lane, and they are coming to the same coming opposite to each other. What they will do, they will collide because they are using the same road without any rule regulation. Okay, so what is happening? Same thing is happening in our LAN network as well. So when multiple devices in the same network are sharing same segment. When they are sharing same segment and they try to transmit simultaneously at the same time, they suppose PCA and PCB both are sharing same segment, and PCA and PCB both wanted to send a message simultaneously. They will come to the same segment because they are using same segment, and they will collide. So message of PCA is also destroyed, message of PCB is also destroyed. That is how collision will take place. So this collision will degrade our bandwidth. So to take care of these things, there are some mechanism came. CSMS CD mechanism came. So there is one more term, collision domain. So what is collision domain? When we'll say collision domain, means in one particular segment how many device can transmit simultaneously, that we can call as collision domain. For example, if we are connected with a hub, so suppose 4 ports are there. So if 4 ports are receiving incoming signal at the same time, all are using same segment here. So what will happen? If one is transmitting, other cannot transmit, other 3 cannot transmit. Similarly, if second port is receiving an incoming signal, other ports cannot transmit at the same time. So at a time only one port can transmit, only one port can forward the message to the common segment, to the common media. So why other cannot transmit? If any other will try to transmit, there will be a collision happen because they are using the same segment for transmitting their data. So this is the problem. This is the collision domain. Like now if we are in switch, and switch also we are having 4 ports, each port can transmit at the same time. So when one port is transmitting, it's not like second port cannot transmit at the same time. So they all are independent. So each port are having their own independent transmission. They are not dependent, their transmission is not dependent on what other ports are doing. So they are independent. So in hub case we have one collision domain. Suppose and in switch, if we have 4 ports, we have 4 collision domain. Why? Because if switch is having 4 ports, one port is transmitting at the same time, second port also can transmit, third can also transmit, fourth can also transmit at the same time. So all ports, present ports can transmit at the same time, and they will not get collided. They will not see any collision. So all 4 ports are representing their own separate collision domain. Okay, now we'll go for CSMS CD. So CSMS CD is a mechanism of avoiding the collision when we are using a common media. So CSMA stands for carrier sense multiple access collision detection. So what they will do, every connected device, they will sense the common segment. If they will see any signal or any communication or any transmission is taking place, they will not transmit, and they will wait for current transmission to stop. So once that is stopped, then only they will start transmitting. So it is a mechanism of removing collision from network. When two or more nodes simultaneously sense the wire and found no frame, and each device places its frame on the wire, this frame would be collide on wire and a collision will occur. So NIC, that is network interface card, actually examine wire before placing any frame on it. This collision detection method is known as CSMS-CD. So what they will do, before any device, before they want to place their frame on the wire, first they will examine what is going on. If they see any collision there, they have to, so if they will see any collision, if the NIC sees a collision for the transmitted frame, they have to resend the frame. In this situation, each NIC that was transmitting a frame when a collision occurred creates a special signal called a jam signal on the wire, waits a small random time period and examine the wire again. If no frame is currently on the wire, NIC will retransmit its original frame again. So what they will do, if they will see a collision there, they will create a special signal, they will call it as jam signal. Jam signal means everything is jam now. So they will wait for a certain amount of time and then they will try to transmit again. The more devices you place on a segment, the more likely you are to experience collision. More devices means more random time interval, creating even more collision, greatly slowing down the device access when trying to transmit data. What will happen? We are keep on waiting and we are keep on trying, and if more devices are there, everyone is trying to transmit, most of the time collision will happen and our data transmission will get delayed. So it is affecting our bandwidth. So now we will come to switch basics. So switches are data link layer devices that switch frames between different layer 2 cable of segments. Different layer 2 cables or segments. See, each port connected to a switch has a separate collision domain. It is simple thing. When you say it is separate collision domain, means whatever you are doing in one port will not affect your other port. Like in switch, simultaneously if you are transmitting, if you have 4 port, port 1, port 2, port 3, port 4, if you are transmitting in port 1, same time you can transmit in port 2 also, same time you can transmit port 3 also, same time you can transmit in port 4 also. It will not create any jam signal in this case, unlike in hub and repeater. In hub and repeater, if 4 ports are there, if port 1 is transmitting, all other ports cannot transmit because it is having only one segment inside the hub or repeater. So what they will do, if one PC1 or port 1 has started transmitting something, what they will do, it will completely make the line wire busy, so all other PCs will not be allowed to transmit. So this is one collision domain. But here in switch, each and every port is having their own collision domain. Own collision domain means whatever I am doing in my port 1 will not decide whether I can do some operation in port 2 or not, or port 3 or not, or port 4 or not. They are completely independent. Same time, if you are doing transmission in port 1, you can do in port 2 also, port 3 also, port 4 also. So they are all independent. So everyone is having their own separate collision domain. Whatever is happening in port 1 will not affect port 2, will not affect port 3, will not affect port 4. So this is what. So each port connected to switch has a separate collision domain. When a frame entered into a port of switch, switch checks FCS. So we'll see that FCS in the next slide. So suppose four ports are there. Four ports are there in the switch, and all four ports are connected to four PCs. So when one PC try to transmit something, what first switch will check? FCS, field of frame, and process it only if it is valid. So FCS, it is a kind of checksum. It will check whether it is valid or not. If it is not valid, it will be dropped. Switch will not process the frame. All valid frames are processed and forwarded to their destination MAC address. So what a switch will do, it will receive the frame. First it will see the FCS. If FCS is valid, it will accept the frame, and then it will receive what is the destination MAC address. Then by seeing the destination MAC address, it will take the decision where it need to go, where it need to be forwarded. So basically switch perform three main tasks: learn where the devices are located and store their location in MAC table, forward the frame intelligently based on MAC address of frame, then removing layer 2 loops. So here you can see, as we discussed, this frame check sequence. So first of all, when switch receives a frame, it will check for the FCS. If this is found valid, then it will check for the destination address. And depending on this destination address, see I have it is given here, switch takes decision based on destination MAC. So whatever is destination MAC is a hardware. It will be defined for particular devices, particular hardware address. So we'll call it as hardware address now. So switch takes decision based on this destination MAC address. So it will see the destination MAC address and it will go to its MAC table, and then depending on the entry in the MAC table, it will take a decision. Okay, now we'll discuss about learning address function of switch. Switch stores MAC address in MAC address table. MAC table is also known as port or CAM address table. So we'll call it as MAC table, port or CAM address table. When a frame enters into the port, switch examines the source MAC address and compares it with its CAM, that is MAC table. When a frame enters into the port, first thing what it will do, it will check the source MAC address and compare it with the MAC table. So if switch does not see a corresponding entry in the CAM table, it will add the source MAC address to the table, including the source port identifier. So it is something like from from port 1, I have received frame from PC1. So source MAC address will be of PC1. So PC1 MAC is received on port 1 of the switch. So it will make an entry in the MAC table saying port 1 with MAC address of PC1. Similarly, PC2 is connected to port 2. What will see? Port 2 and MAC entry of PC2. That we'll see in the later section how it will happen. So if switch found address in CAM table, then compare associated entries and update them. Whenever the switch updates an entry in the CAM table, the switch also resets the timer for a specific entry. So these entries will be there for some time. Whatever we have learned, it will remain there for some time. So it will find any new entry and it will make any entry newly. It will update any entry in the CAM table. The switch also reset the timer for the specific entry. Switch uses timer to remove older information automatically. Switch may have different default timer. So there is some default timer value after which older information will get removed and again data will be learned newly. So as in the frame you can see this destination address, source address. The source address is the source MAC address from which this frame has come. So this is just header part. This is the frame. In this frame, this is our actual data. So this is the data. All other things are, this is header and this is and part of the frame. In between, data will be there. So you can see length, source MAC address, destination MAC address, SFD and preamble. So need not to it is simple thing, like it is a plain format. Everything is having their significance. Preamble and SFD will tell us where exactly our frame body is going to start, and then this destination MAC address and source MAC address. For now you can just understand it like depending on our destination MAC address, our switch will take the decision. MAC address table can be built statically or dynamically. All dynamic entries are automatically flushed when you turn off the switch. So once you turn off the switch, all the entries will be gone, whatever is learned dynamically. Dynamically means like you have received something and you have made switch has received something, so received some frame, and then it has make an entry saying, okay, in this particular port this PC is present, in PC1 this PC is present, in port 1 PC1 is present, port 2 PC2 is present. So that is we'll call as dynamic entry. How they have made the entry? Just by reading the frame, they have got to know at this port PC1 is present, at this port PC2 is present. This will call as dynamic. Static means we are logging inside the switch and we are making the entry manually. When you power on is, so whatever dynamic entries will be there, that will get flushed off when you turn off the PC. When you power on a switch, it has empty CAM table or static entries in it. So whatever static entry will be there, that will remain there. That will not go. So all identified frames are forwarded only from specific ports that have corresponding address. So suppose something, two scenario we can say, we have received a frame whose destination MAC entry is present in our MAC table. For example, PC1, which is connected to port 1 of the switch, want to transmit the data to PC2, which is connected to port 2 of the switch. So port 2 is connected to PC2, port 1 is connected to PC1, and both PC's data are present, entry is present in our MAC table, in our switch MAC table. Like port 1 switch is having a MAC table, it is saying PC1 is present at port 1, PC2 is present at port 2. Now if I'll receive a frame from PC1 saying destination MAC of PC2. You'll see the frame, you'll see this frame here, and it will show like I want to send my data to PC2's MAC address. In destination address it is showing as PC2's MAC address. So what it will do, it is an identified frame. So even though it is having 4 ports, PC1, PC2, PC3, port 1, port 2, port 3, port 4. So what it will do, it has found out like PC2 address is found at port 2 in the MAC table. As we learned previously, in the MAC table, MAC address table, it is showing PC2 is present at the port 2. So what it will do, it will just send it to PC2. But if that destination MAC address, that is, suppose PC2's MAC address is not present in the switch MAC table, okay, what it will do, it will receive from PC1 one port, it will receive the frame, switch will receive the frame, and it will broadcast it to all the, it will flood it to all the other ports except from the one it has received. So PC from port 1, switch has received something, it is having 4 ports, port 1, port 2, port 3, port 4. So if it has received something from port 1 and entry is not found in the MAC table, that we can say it is unknown or an unidentified frame, what we are calling as. So in this case we don't have entry of the destination MAC into our table. So what it will do, it will just flood the frame to all the other port except the port from where it has received. So it has received from port 1, now it will flood it to all the other 4 ports, all the other 3 ports, port 2, port 3, port 4. Why? Because it has not found destination MAC entry into the MAC table. So 3 types of frames: unknown unicast address frame, broadcast frame, and multicast frame. From all possible ports except to the so 3 types of frames, like unknown unicast address frame. As we discussed, unknown means unidentified, which for the frame destination MAC entry is not found into the MAC table, one thing. Second thing is broadcast frame. Broadcast frame means destination MAC will be FFFF, so that is a special frame that is mean for broadcasting itself. And then multicast frame, these are always flood out. Flood out means from the port it has received, except that port, it will get forwarded to all the other ports. So from where it has came in, except that port, that frame will get flooded to all the other ports. It is a simple example. You can see here PC0, PC1, PC2, PC3. PC0, PC1, PC2, PC3. PC0 is having MAC address of 00000000. PC1 is having MAC address of 111111. PC2 is having 22. PC3 is having 33. So it will see here PC0 sends a frame to PC2. So PC0 sends a frame to PC2. So source MAC will be 0000, destination MAC will be PC2's MAC address 2222. Now switch takes, as we know, when we will start, first of all assume our switch is completely clear, it is not having any entry, it is turned on freshly. What will happen? MAC address will be empty, as I told. Like only static entry will be present, whatever learned dynamically that will be gone. It will turn off the switch. So in this case PC0 sends a frame to PC2, switch receives this frame on Ethernet 0/1, as you can see in the diagram here. This is suppose 0/1, or you can say port 1. So PC0 sends a frame, switch 0 will receive it. So destination, whatever it has received, switch take 3 steps here: learn, decision and forward. In the first step, switch updates MAC address table with source address and learning interface. So first of all, what it will do? It will perform learning. So when it has received the frame from PC0, it will update the MAC address table with the source address and learning interface. So what is the source address here? Source address is 00000, because PC0 has sent this, so PC0 is the source, and from which port we have received this frame is 0/1. So switch has received from 0/1 is, so it has learned at 00, at 01, at Ethernet 01, at Ethernet 01, what is present? We have PC0 is present, whose MAC address is 000. So same thing it will update in the table. So first thing it will do, learning. MAC address table is currently empty. It looks in MAC address table for entry of source address. So first of all, it will check the entry in the MAC address table. It has not found anything, so obviously it would not find an entry for it. It will make a new entry for this address. So new entry will be made in such a way like PC0 MAC address, that is 0000, is present at Ethernet 0/1. Now in second step, it will take the forwarding decision based on destination address. This frame has a single destination PC2. So single destination frame is known as unicast. Switch has, since we already told, table is currently empty because it has started freshly. So freshly, when we will start, there is no dynamic entries will be present. What it will do? It will try to match when it has C1 destination, single destination address, it is for PC2. What it will try to do? It will try to find out a match into the MAC table. But in MAC table, we don't have any entry. We have only one entry, that is for PC0 at port Ethernet 0/1. What it will do? Switch has no entry for this destination address in MAC address table, so it will treat this as unknown unicast. Switch floods unknown unicast from all possible ports. So in this case, it will flood to all possible ports. Flooding to all possible ports means except from the one it has received. So PC0 has sent a frame, it has received into the switch. Now switch, what it will do, because it has not found the entry for PC2's MAC address into the table, what it will do, it will send to PC1, PC2, PC3 because it is unknown unicast. Unknown unicast means destination MAC address is not found into the switch MAC table. So in third step, switch takes action based on the decision made in second step. So first of all it has learned, then decision taken, then it has come into action. Come into action means now it has been decided like it need to be flooded. So in all the ports it will get flooded except incoming port. So incoming port is this one, that is Ethernet 0/1. Other than this, it will get forwarded to all the possible ports saying 1, 2, 3. So all the other ports except incoming port, it will get flooded. So you can see learning address function of switch continued. Now MAC address table look like as following. This is the first step. What happened? So you can see MAC address 0000 is present at Ethernet 0/1. So this is how first entry is made into the MAC address table. MAC address and port. It is showing at this MAC address this particular MAC address is present. Now learning address function of switch continue. So what will happen, this frame would be received by PC1, PC2, PC3. As I told, it is getting flooded to all the other port except the incoming port. So incoming port was Ethernet 0/1. So except 0/1, all the other port it will get flooded. So PC1, PC2 and PC3 will receive this frame. PC1 and PC3 will drop this frame as it is not intended for them. How it will get to know? Because they will check the destination address. So destination address belongs to PC2, that is 22222.2222.2222. So that MAC address is destination MAC address of PC2. So all the other PC, when they will see the destination MAC, they will discard the frame saying it is not for me. So only PC2 will process this frame because it has found out its own destination MAC address into the frame. So it has reached to the destination. Now PC2 sends a frame back to PC0. So PC2, what it will do, because it has received a frame, it will respond back to PC0. Switch received this frame on Ethernet 0/3. So you can see here, this is 0/1, this is 0/2, this is 0/3. So when PC2 will send back a frame to responding PC0's frame, PC2 will respond with the frame saying in learning switch received this frame on Ethernet 0/3. Now again switch takes 3 steps when it receives a frame on its interface. What it will do, again it will take 3 steps to make the decision. In learning process, switch checks MAC address table for entry of source address. It is the first frame from PC2. Switch has no entry for its source address, so it would update MAC address table. So it is like first what we discussed. First of all, it will check the source address. So source address entry is not found. So this time it will make an entry like port 0/3 presents 2.2.2.2.2.2. So PC2's MAC address. So in decision making process, which compare destination address with MAC address table. So this time it is not an unknown unicast. This time what it will do, it is a known unicast. What is the difference between unknown and known unicast? Last time destination MAC address entry was not present in the MAC table, but this time PCA's MAC address MAC table entry is present in the PC1's destination MAC, that is MAC entry is present in the MAC table. So what it will do, it will see the destination as 000. When it will see the destination address, it will compare the MAC table. In the MAC table, it has found out the entry at 0/1 0000, that is PC1 is present. So what it will do, now it will take the it is able to make the decision. So now it will forward process will happen. Switch only forward this frame from its Ethernet 0/14. So you can see here, switch repeat this steps every time whenever it receives a frame. You can view MAC address table entries from show MAC address table command. So you can see here it is showing 0000 at Ethernet 0/1, which this entry was made in the first time when PC1 has sent a frame, which was unknown unicast because this second line was not present. When second PC2 has sent a frame back, that time this entry, second entry, has come and it is learned by the switch, and when it has seen the destination MAC address as 000, it has become known unicast, and that time our frame will go only to Ethernet 0/1 port. So remaining things related to switching concept analysis and spanning tree we'll discuss in the next session and in next videos. Thank you.